We're here today at VF Engineering with Nick, the founder of VF.
Hi, Mike.
And he is going to show us their new badass A90 Supra intake manifold. Now we tested this sucker and it's really impressive. And the engineering behind it is really cool too. So why don't you take it from the top?
Sure. Well, we've been tuning the software and the ECU in the Supras since the car came out and seeing a nice, comfortable gain. We don't want to really push the turbo too hard because that creates more heat. So while we were searching for more power, we naturally looked at the cooling capacity of the car. As you know, cooling is everything, right, for these cars to make power. It's a pretty tightly packed engine bay, and the first place to start is the cooling for the forced induction system. The stock intake manifold's got the integrated air-to-water heat exchanger, and you can see the core inside there. It's a pretty good density core. It's well packaged, but we've seen that on the aftermarket that a lot of guys that have really yanked up the power have found the physical limits of the stock manifold. So we decided to scan it, and you can see some of the residue from the powder we apply, and we use a white light scanner, scan all the critical surfaces, the key mounting interfaces, and a lot of the mounting pads for the accessories, and then we set it all up in SolidWorks. And then we go about really like looking to find an envelope in which we can fit the largest core possible. And that's where we came to this here, 3D printed. We have a printer in-house. It's a filament printer, so it's a very quick and simple piece. We've got a lot of the bracketry assembled, and you can see we've actually created an air tank. That's the hot side, and then the piece in the middle, this rectangular section, represents the heat exchanger core, and then the cold side, the discharge side, which is the intake runners, which mate to the cylinder head, and they accommodate the original O-rings. So our design principles are based around keeping the, as much of the original design concepts as possible. So when we want an enthusiast to install one of our parts, we want them to be able to just fit it in without any other modifications or as few modifications as possible. So one of the key things in this design was to maintain the mounting points for the manifold and maintain fitment with the valve cover and the valley that we're dealing with a lot of ancillaries for the factory emissions components to reside in. And then a couple of trick things we've done with the manifold is accommodate additional injectors. So you got one missing here, but you get the concept. These are 3D printed to simulate, and then we make a rail, we've got some mounts. So this accommodates additional fueling.
So you can run a combination of the direct injection and port injection.
Exactly, because there's only so much fuel you're going to get from those direct injectors before you've got to find some better ones. And you know, on these engines, the combustion pattern is so critical for making good power. You know, you could put in a lot of boost and not make as much power as some other guys if you don't get the combustion quality right. So your choice of injectors, your spray angles, your spray patterns, and your fuel pressures are so critical, right? And we can bring the temperature of the charged combustion down by using a larger core, a really efficient core. So to get the most out of the core, we have to really ensure that we're getting good distribution of air across the entire core, because it's a pretty long core, and actually it's a pretty tall core. And the areas that we see typically that are challenging are the end of the core and the beginning of the core. So you can imagine as the air is traveling in through the throttle body, it kind of washes down the back and makes its way in. So what we've done is we've designed a divider on the inside. You can see that this is the finished piece. You can see a divider inside there.
Yeah, right here.
Right, and that's been carefully placed to really provide and reduce as much turbulence as possible. So we played around in our CAD software with dividers in different locations, and then we could experiment and see where we were getting air turbulence, how much, and we could see all kinds of interesting things happening. It's a bit like guys on a rally going through traffic, right? Path of least resistance.
I mean, I see some interesting design features, like the changes in not only like the taper, but cross-sectional area.
Yeah.
And some features like this. And was this all through development with CFD that you came up with some of these interesting...
It very much was. I mean, from the outset, from the very beginning of the project, one of the most important things for us was to ensure even airflow across that. And so the only way to really test that in theory was with, fluid dynamics in SolidWorks software to simulate how that would work in theory. And then we've also got a lot of practical experience in making these types of manifolds for our supercharged applications, where we make very, very similar intake manifolds with integrated air-to-water heat exchangers.
I guess like we could actually show that better to our audience with this one. But as you can see, it's not just a simple plenum, but there's actual like complex changes in the cross-sectional area, the taper, some features like this. And that's all to help the flow get in the back cylinders, right?
So the angles and the tapers dictate the speed of the air and actually the path of the air. So the divider inside will also act as a funnel in combination with the shape of the exterior profile to ensure that we get air traveling evenly to the back, because it's critical to get as much air from the end into the end cylinder as it is in the middle cylinders, or you get an uneven distribution or load on the crank.
And that's something that like typically your customer base wouldn't catch on to, but then that's like actually really damn clever.
Right, thank you. Yeah, most would think that that is just an aesthetic feature, but there's always something going on somewhere, and not everything is as obvious as it may seem. Some of these features over here and these angles here they all have a purpose, all have a practical purpose, and are not just a physical feature.
It's all to help the air to make the corner and stuff.
Using as much of the core as possible is going to get us as much efficiency as possible. We've seen through some prototype testing years ago how certain shapes of end tanks that we made would concentrate the air through just a very specific part of the core. And then when you remove the manifold, you can see a buildup of, or a trace of residue where the air is most commonly traveling. And that's often where you get to see the limitations of that design.
And that's something like your PVC residue or something that...
Exactly. The recirculating crankcase vent is actually creating a nice trace of where the air is traveling.
The other things I noticed is that your core has a lot more frontal area. I mean, that's at least 4 inches, right?
It is. This is approximately 100 centimeters by 100 millimeters by 100 millimeters square. And the core, which I know CSF will talk about, is actually a pretty interesting design. It's a very high-tech core, and we wanted to make sure that we did it justice by getting as much air to the entire cross-section as possible.
And normally, frontal area is one of the most important things when you're designing heat exchangers.
Right, so surface area and depth.
And it's almost twice as much as the stock one when you look in there.
Yeah, I mean, you can see the stock core it's quite narrow indeed. Depth-wise, we're slightly longer. We've got slightly longer distance that the air is traveling, which gives it more room to dissipate the heat and transfer it into the liquid traveling through the core.
You also have a fuel rail that's for your top feed injectors.
Exactly. So this comes with the manifold, and it's designed to basically allow you to use either the shorties or the regular standard size injectors. You can use either size, and it allows you to plumb in through the front and the back. So you've got a nice return fuel system there, and that's all included with this kit. It also comes with bungs, so if you don't want to run extra injectors, you don't need to. And on top of that, you've got ports for nitrous. So that's also added in the design, and then that comes capped off. So it's an optional feature.
So you have intercylinder cooling from the direct injection, and also the attendant increases the VE that creates. Plus you have some more charge cooling with like top feeds. Right. If you run something like ethanol, you could probably push this engine pretty good safely.
Right, so now we're at the limits of how big your turbo is and how well built your engine is.
Well, very impressive. I mean, this makes me almost want to buy a Supra. Good job, man.
Thanks, Mike.
You're the core master.
That's me. That's my part of the project. So, Mike, I know you and I have worked a lot together, and you've seen a lot of the different cores we've done for oil coolers, obviously radiators, air-to-air intercoolers, and now we're talking about our latest and greatest water-to-air charge cooler.
Now, Nick said this is a really trick core, so what do you got going on with it?
We spec'd a variation of different cores, wanted to find the absolute lightest and thinnest materials that we could find to be able to make this core, to be able to dissipate the heat as fast as possible. We decided to go with a bar and plate core, and the core has actually got 12 rows of water cooling compared to the OEM core that I think has only 6 rows. So it's got twice as much cooling surface area as the OEM. And that's why the results that we're starting to see are so good.
Yeah, the dyno results were amazing.
Yeah, I mean, from what we saw from our preliminary testing, over 100-degree drops, very consistent temperatures, run after run. That's really what we're targeting because, we're making this obviously for any Supra owner who wants to have it on their car, but we're really targeting the upper echelon of drag racing, motorsports, in terms of guys who are doing endurance racing, track racing. So guys who can really take advantage of the cooler.
One of the things too is that in the Supra, there's a lot of stuff going on in the front, so you really can't just rip the front apart and put an air-to-air in there.
Underneath the Supra is really a BMW, and a lot of these cars are now made very similarly, which is there's a cooling pack in the front, and that contains the engine water radiator, also the water radiator that cools the charge air water, so an independent radiator that's got the water cooling down, which then goes through the cooler. Then they also have a transmission cooler in front. Some of them even have an AC condenser. So all of that really limits the ability to do drastic changes in terms of putting a bigger air-to-air intercooler. That's usually the easiest, and that used to be what used to be so prominent on, the old school Supras like the MK4s. Now we really have to spend a lot of time with designing, CFD analysis, the core spec, to be able to make something that actually works better in the car.
And CSF is going to come out with a whole that whole cooling module, right, with all the heat exchangers.
Absolutely, and actually we already have all of those other products on the market already. So we already make the front mount heat exchanger, which in addition to this is going to give you the absolute best temperature control for your engine and your charge air cooling system. The auxiliary radiators that go right underneath the headlights that give you extra cooling for the charge air system, and also the engine water system, and we also make a race spec transmission oil cooler. So those parts we already have on the market. We sell that in a 4-piece kit. This is going to be the 5th piece to that new product line that we have for the G-Series BMWs and A90, A91 Toyota Supras.
So on the dyno, we saw 100 to 120 degree charge air difference across the core, and we also found really quick recovery after the dyno pull. Like by the time the dyno wound down and we're getting ready to make another one, it just about recovered almost to the regular condition. Now that's super impressive. Like normally I'm not a fan of water to air, generally because the you can't get that frontal area, and the heat exchange, although like heat exchanger itself is more efficient, you're usually so limited in area it kind of is less than a wash. But man, this thing kicks ass.
And if you get into the nitty-gritty details of what the core is, like, yes, I said it's a bar and plate core, it's got 12 rows, but we can talk about the super short fin height that we're using. We're using a 2 millimeter water channel, and we're using a 5 millimeter or 4.83 millimeter to be exact air channel. So those shorter fins, more dense, gives you more surface area to dissipate the heat, which allows you to get more rows of cooling in terms of water flowing through the core, which ultimately brings down your intake air temperatures. So, we really sat down, Nick and I, and talked about every single component, whether it's the brazing sheet thickness, whether it's the fin height, the fin thicknesses, the bar, the spacing for the divider in the back, also even these front and back plates of the core. How much distance do we need for the water to return so there's no cavitation? So we really both used all of our knowledge and experience from Nick's you know, 30 plus years in this business, from mine, you know, 12 plus years in this business, to be really able to put it all in one package. You know, this is the second time Nick and I have done a project together. Our first one was for the BMW S55 engine, and that's been wildly successful. So, you know, I approached him, I said, let's run it back, and let's come up with something that kind of really challenges us both. And I definitely think this new project has. So we're very excited about it.
Yeah, I mean, this is the best performing compact water-to-air intercooler I've seen.
I appreciate that, Mike. And it's really great to have MotoIQ here, just to be able to witness the test, validate it. You know, everyone really holds your guys' company in high regard for, you know, no BS. You're only going to promote and, you know, put it out there what the real data results are. So we're happy to have you here to be on site.
With all that, let me qualify that a little. I mean, I've seen water-to-air ones that create a bigger delta across the core, but of course those were like drag race or our Bonneville car where we had like no space constraints, so we had a huge core and we had ice tanks and huge heat exchangers. But considering that this all fits within the OEM space, I mean, it's highly efficient, and I'm really impressed with the results.
And thanks, Mike. And you know, this product that you're seeing here right now is actually a prototype. So it's our first billet prototype. There's going to be some other features that we've implemented onto the production one. You know, we're going to have some of these bosses just to be a little bit more aesthetically pleasing, but still allow for the engine cover to sit on top. You know, another feature that's really cool here, this divot in the bottom of the tank is actually so you can get to the oil filter. So you don't have to remove the whole manifold to be able to spin off the filter and to be able to do a quick oil change. That's especially important for the drag race guys because they're always changing their oil. Track guys are always changing their oil. You don't have to remove the you know, the manifold every time you want to get to that point. So,
I don't think I want to do that even as a regular person.
So, you know, and that's why Nick was able to counterbalance it with this hump just to make sure the flow was, you know, proper all the way to the end of the core. You know, like I said, the fuel rail is going to come with it. We're actually going to also be putting a pad on this side that's got extra vacuum ports and extra 1/8 MPTs, just so you can measure more parameters. Something that we think that, you know, higher end race guys want to be able to take control of. ECU tech software or whatever other plug and plays are going to be coming to the market.
So the production one, you're going to have two different end tank configurations, cast and billet.
So exactly, Mike. This was, you know, we wanted to make the billet ones to get the product out to market. We saw that there was a demand for it and there was definitely a need. We also wanted to make sure that our design was perfectly fit. So, you know, we were going to have to make a billet one anyways, just to be able to test the concept and make sure it works. So we said we might as well come to market with a limited edition run of 50 billet coolers, and hopefully by SEMA, we'll have a cast version that's a little bit at a lower price point for mass market.
I bet you these are going to sell out the first day that...
You know, just from the pictures that, you know, VF Engineering and myself and Custom Plenum Creations, who we commissioned in Australia to machine this, once we started putting the pictures, I mean, our phone hasn't stopped ringing. So we're really excited about the response that the Supra and BMW G Series market has, you know, put towards this.
So sign up for yours now.
Mike, I really appreciate it. And, you know, we're going to be releasing this product around the beginning of July. So, you know, check out csfrace.com for more information. In about 2 weeks, which would be about June 15th, we're going to be releasing the pricing, where you can buy the products, and all the different components that you can buy as a package. I'd also like to give a big shout out to Robert from Studio RSR for allowing us to borrow his car and to use it. He's been a very good development partner for us, not only on the Supra, but BMW cars as well. So he'll be one of our West Coast dealers, as well as Titan Motorsports on the East Coast and P-Tuned. And all of our distributors will also be able to carry this for other shops who want to be able to get their hands on this. So yeah, stay tuned, stay plugged into our website and our social media, and there'll be more information there.
So that's the part and all its features. Let's go see how it works.
How are you? Good, good. Oh shit, you're still going?
Yeah.
starts to pulse, and basically what we're trying to do is be consistent with every single pulse. So every single one will be 30 seconds. So he's keeping an eye on me so I can tell him where the 30-second mark is. That way when we look at our data, it's not like a 20-second round, a 35-second round, a 40. We keep it consistent at 30.
So we did our physical testing, and then we took a bunch of data. Now what we did is we measured coolant temperature in and out of the core, and we also measured temperature drop across the heat exchanger for the engine. This thing works awesome.
Awesome.
So when you look at the dyno data, these are the kind of like the average. So what we did is we didn't take the super good flyers that were when everything was cool. We waited till it was in saturation, and we picked dyno runs at that time. So they're kind of like the average. But what you see here is we're getting at least 20 more horsepower and 10 to 11 foot-pounds more torque. Now if we took flyers, it would be 30 more horsepower and 15, 16 more foot-pounds of torque, but we wanted a good, honest, average approximation of the power that you should get. So that's outstanding just for an intercooler.
Yeah, I think that's really important, Mike. You know, being in the industry for a long time, Nick even longer than me, is we've seen so many companies, you know, fudge their dyno graphs just for marketing in terms of how they put the product out. They take the best dyno graph, you know, on their new product versus the OEM.
And the worst of the OEM.
They say this is the Delta, and that's really not the case. And that's why I think it was important we brought you guys in here to give like a no BS answer on how the cooler really does work. So we're really excited to see that, you know, in the middle of all these runs, I think we did about, you know, 20 to 30 on both the stock cooler and our new high performance cooler, that we're seeing those gains of, you know, 20 to 25 horsepower.
Some of the profound things are too is that some of the numbers are so much better that, you know, this was just A to B testing, but you could actually do a tune just around the intercooler and the gains would be even better. Or conversely, you know, if you put a bigger turbo in and, you know, if the engine was more aggressive, the differences would be even huger. So let's go look at the data so we can explain some of this stuff. So this is the temperature of the stock core. This is air temp for the engine, and this is the, this is the air temp for the engine, and this is from the compressor discharge temp. And you could see how wide the delta is, and this is kind of interesting, so watch this. So here's the CSF core. Now when you notice the temperature post the brick is only 5 or 6 degrees cooler, but that doesn't tell the whole story. The big thing is the compressor discharge temperature is 30 degrees lower. So what this tells me is the pressure drop across the brick is a lot less, and it's markedly less. There's so much less restriction that the compressor is in a whole more efficient part of the map. And I mean, the drop at 30 degrees, that means that for this tune, you're like way, kind of like in one of the more outer islands, and now you're more centered in the efficiency. Your temperature going into the core is a lot lower, so there's a lot less BTU to take out of the stream. So maybe that's why the this isn't that much lower, but this is a lot lower. But heat is heat, and although you might think, well, maybe that's not too impressive, it actually is, because the compressor is working a lot less harder, so it's a cascading effect. The compressor is using less power, so the turbine has to recover a lot less power. So that means the back pressure is a lot lower. So you're seeing a cascading effect of how the engine is going from a holistic standpoint. You know, since you don't have so much back pressure and the air isn't so hot, the thermal load on the engine is a lot less too. So, and the volumetric efficiency is better because the turbine isn't being the cork as much. So it's like a big effect that's not so apparent when you look at the raw numbers. But I mean, this number here is really impressive. The CSF core, the temperature is much more consistent from the first runs to when you achieve saturation. That's because the thermal capacity of the core is more. It's less, these are more narrow, so it's rejecting heat quicker. Overall, it's much better, very impressive. So this is the stock intercooler in and out. Now, we have your CSF water heat exchanger on there, so it's actually cooling the water much better than the stock one. So it's actually making the stock intercooler look kind of better. And with the CSF, you notice that the peaks are lower, it's more consistent, and like the fluctuation is a lot less. So that shows that this brick is working a lot better. I mean, it's markedly different.
Yeah, we're really excited about it, Mike, just because, you know, we tested this on a 400 horsepower car, and when Nick and I decided to go into engineering this product, we were looking at really wanting to lead the Supra and B58 engine market for guys who are doing 600 horsepower, 700, 800 horsepower, a lot of the drag race guys, high-end endurance motorsports guys who want to do big turbo on the streets. And we're, Nick, what do you think? I mean, we're pretty much seeing what we need to see with the gains that we've gotten from this cooler.
Definitely. So back-to-back testing on the same tune, in the same conditions, so on the same day, has shown such a big delta, and that's what we're looking for on the dyno. So the manifold and the core, the heat exchanger core, have given the user, the enthusiast, so much headroom for expansion and power. As you said, you know, we've tested this on a low power variation, so and we have so much headroom from bringing so much cooling capacity. And as we all know, engines are limited by cooling capacity. That's the peak challenge that most engines have. So reducing the temps and giving the room for expansion and growth for the enthusiasts allows them to target more horsepower.
The other thing too is that your brick has so much less restriction. I mean, it's visually obvious when you see it that when you increase the mass flow with like a bigger turbo, that's actually going to be way more beneficial. The compressor's going to slide into a way less efficient part of the map, and then the turbine's going to have to extract more energy, and then it's that whole back pressure thing. So the motor's going to be a lot happier.
It's going to be happier, and then not only is that the positive effect of the manifold, but we've got the additional options for extra injection ports, for nitrous and for fuel. So the load on those systems is going to be less. So enthusiasts might not have to rely on those systems as much for their cooling.
And it'll be really awesome too. You're going to have the cylinder cooling from the direct injection, and you're also going to have the charge air additional cooling from the regular conventional injectors too.
Exactly.
Yeah, I think when you start to put all these features together, you know, we've really come out with a industry-leading product that I think any, you know, B58 engine owner is going to be excited to have on their vehicles. You know, especially as the platform continues to progress, guys start to challenge themselves and their vehicles with more horsepower. You know, wanting to do different types of motorsports. And you know, when we tested this cooler, which was about 2 weeks ago, we've really been able to digest a lot of the data. But not just that. Nick's been working really hard on improving the design so that when people do get the final production version, you know, at the end of this month, you know, beginning of July, there's going to be a lot more things that, you know, real enthusiasts want to have. We've added a pad on the inlet side with some extra, you know, ports to measure different types of vacuum, just to be able to have a little bit more of a sensor. We've actually redesigned the back water plate to work with very popular flex fuel kits in the market, like the Visconti tuning. And you know, we've made sure that all of the things that do happen with a prototype have been fixed. So you're really going to get a drop-in fit product that was well engineered and is ready to go into the vehicle. So we're really excited about that. Nick still got a couple extra weeks, in terms of putting the kit and hardware list together. So when a user or an enthusiast does get this kit, they're going to have everything they need to do this as a true plug and play, even for something as advanced as this new Manifold charged air cooler.
One thing that our audience might say too is, well, why don't you just put a big front mounted air-to-air in the front? But the Supra, the engine compartment is really tightly packed, and the front of the car, in front of the radiator, is really tightly packed too, because the car has the low nose, and there's a lot of stuff in there. So the air-to-air wouldn't package that well, right, guys?
Yeah, I mean, air-to-air also has limited cooling depending on the air aperture at the front of the car. One of the bigger advantages of air-to-water is not only the factory chose to use it, but we chose to enlarge it because, as you know, water has a greater propensity to conduct heat out of the air charge than ambient air.
So our test methodology is we got some different sensors. So we got temperature thermocouples before and after the intercooler core, and we also measured the coolant temp before and after the coolant heat exchanger also. And so when we had our dyno results, it would be easy to cherry pick some of these initial runs when everything's nice and cool. But what we did is we did a realistic A to B comparison. So we waited until the system reached equilibrium and heat saturation. So we picked runs in this zone right here. So this is a good, fairly conservative result, and it's not cherry picked, and it's, I guess, a good solid example of what you can expect. And then Nick, we had some other interesting results, right? So when we're testing the stock system, once we reached heat saturation, right at the end, the engine went into a protection mode, right?
That's right, because we were being really aggressive with the car and the dynojet, and you were giving us the signal for timed pulls, right? Mm-hmm. Every 30 seconds we were giving it a hit, and we did approximately 30 pulls back to back non-stop. So the air circulation within our facility is also limited. So we were sort of strangling the car somewhat, but basically putting it through its worst case scenario.
And the engine went into protection mode, and it pulled out about 40% of the power, right?
It did. The dyno curves looked almost as if they were back to stock. And the car has our software, our tuning software, and a performance exhaust, and that was with the stock setup.
And so with the upgraded intercooler, we did the same thing, and it was consistent all the way through, and no protection mode, right?
Exactly. It performed really well with our manifold. The car didn't exhibit any signs of overheating throughout any of our tests. In fact, the car performed really well consistently. So one thing that was really important for us and for your results and data collection was just consistency of the conditions. So the dynojet that we used, the fuel wasn't changed in the car, and all the conditions, even the temperatures were fairly close between the testing of the stock versus the billet piece, were all consistent.
Now, I know in the Supra community, guys that do track events, power fade is a big deal. It's from what I've been reading on the forums and stuff, and I'm pretty sure with this and the other heat exchangers, that completely eliminates that issue, even on track-driven cars on hot days, right?
Absolutely. After we had done the testing here at VF Engineering, our test car, who's owned by Robert at Studio RSR, had gone to that weekend's TRD Challenge, and he actually placed first.
Yeah, it was at Cal Speedway, right?
Yes, and it's hot. It was probably in the 90s, mm-hmm. And he likes it so much. I tried to ask him for the Manifold. He's like, my car has never ran so good. I want to keep it. So we're still trying to grab the test one back, but it just goes to show, that the car, has had limitations, especially on the track. In terms of the longevity of consistent and optimal power, and when you add our cooling system, you really get to enjoy your time on the track. Your car can go longer, and I think this is going to be great because there's a lot of people out there doing different types of motorsports, whether it's drag setups where they actually need all the features in terms of like the nitrous injection and the secondary fuel rail, to track guys who just need a better cooler to kind of get them around and being able to do all the endurance that they need at the track.
A larger water cooler from CSF is going to complement this really well.
Yeah, and you know, with that, Mike, there's always a guy who's out there willing to hack up his car, right? He wants to add piping and, you know, fit an intercooler and do something unique. For us, when we sat down to design and bring this product to market, it was really how not just super hardcore racers can benefit from this upgraded cooling kit, but every person who's purchased, you know, a car can go get this cooler, you know, complement it with other coolers from CSF and really have a cooling package that they can use then to use to upgrade the performance of their vehicle. And, you know, if they have a leased car and they want to return it to stock, this is something they could do that with as well. There's nothing that has to be modified or hacked up to be able to install this. And I think, you know, on behalf of VF and CSF, we're really proud about that fact.
Yeah, we put a lot of attention to the details for the fitment and placement of the original sensors, the wiring harness. There's also the opportunity to hide and tuck some of that if you want to. We've minimized some of the pads, the bosses for aesthetic appearance. We've given some great fitting locations for the mounting brackets and all the additional injector ports. So all in all, we've really sort of paid attention to installation ease. How can you install this as simply and as easily as possible and not need a professional to necessarily install it?
Well, this is a really great product, guys. And the big question is, when is it going to be available? And yeah, how soon can somebody with a Supra get these?
So some of our dealers are already taking pre-orders, and we are targeting that these manifold charge air coolers will be available on the market, ready to ship about the first or second week of July.
Okay.
So, you know, we're about the middle of June right now, so I would say in about 3 weeks, these will be shipping out to customers, and yeah, we're really excited. It's in the middle of summer, it's really hot outside, and the benefit of it's going to be truly realized once guys put this on their cars.
And that's going to be the billet version or the cast one?
That will be the billet version. We are still finalizing the pricing, but we're targeting it to be about $42.99 or a little bit less. And it's going to come with the additional fuel rail, all the instructions, all the hardware that's needed, all the hoses, fittings, everything that you need to be able to put this in the vehicle. And you can buy it from any one of CSF's authorized dealers, and it will be for the billet. And we are now targeting, since we've now finalized the design, a cast version that will be available within the next 6 to 8 months.
Okay. And how much is the cast one are you targeting?
We haven't targeted a price yet. We're still in the design and development phase. You know, with the fluctuations of raw materials, transportation, and so many other costs that are happening, you know, this year in 2021, we prefer not to release that information until we have a better idea.
So if you have a A90 or an A91 Supra, this is the thing, man. You guys you gotta get it.
Well, we appreciate it. Nick, thank you for all the hard work. Thanks for hosting us, for all the hospitality, for letting us use your dyno, your engineering expertise. It's been great to do another project with you. Mike, it's great to have MotoIQ here to just be on board, to witness the results and the performance of the manifold, and really give us you know, that authorization that MotoIQ was here. This was a third-party validated test, and we really hope that everyone who watches this video is gonna, you know, have all the answers they need to be a confident purchase.
So if you like this video, you like our technical content, be sure to help us out and subscribe to our channel. If you want to read about it in detail, go to motoiq.com and check it out.